Welcome to Maths with EJD. In this video, I will be talking about the stepping stone method for transportation problem optimization. I've said it previously that when in solving a transportation problem, right, the first thing you get will be the initial feasible solution, and the methods to get this initial feasible solution can be either the northwest corner rule, which I've made a video on, northwest corner rule. Another method will be the least cost method, least cost method. And of course, the um, Vogel's approximation method, Vogel's approximation method. Okay, so with these methods, you can actually find the initial feasible solution. So after finding that, now the initial feasible solution can be the optimal solution and it may not be. But how do you optimize, right? For optimal solution now, for optimal solution, you now need other methods. You need other methods like what we are considering today. That is the stepping stone method. You can use the stepping stone method, or what you can, the other one is the modified distribution, modified distribution, otherwise known as the MODI method. Okay. So I've made three separate videos talking about northwest corner, least cost, and Vogel's approximation methods. So now I'm making so this particular video is on the stepping stone method to optimize whatever initial visible solution you have got from any of the three methods. So I'll do stepping stone now, then I will do modified distribution in the next video. So let's talk about the stepping stone method here. Stepping stone method. So, I mean, as the name implies, right? It's more like you're looking for a place to start. Okay, that's what exactly stepping stone is about. You're looking for a place to start a journey. So, um, the stepping stone method is a technique used in transportation problems to find the optimal solution for minimizing transportation costs. Okay. Um, and let's consider the steps in stepping stone method. Steps in stepping stone method. Well, the first thing is to find the stepping stone and then move on from there. So first, oh, okay, well, maybe not the first, right? You need to first of all identify an initial feasible solution, which you would have derived using any of the northwest corner rule, least cost method of Vogel's approximation. So the first step is to identify the initial feasible solution. Identify the initial feasible solution. Okay. So in this case now, so you start with an initial an initial basic feasible solution. Okay. And it is often found using methods like the northwest the northwest corner rule, let me just call that NCR, or the least cost method, or the Vogel's approximation method, VAM, and all that, right? Then the second step is to now improve the solution, improve the solution, improve the solution so that here you evaluate potential improvements, evaluate potential improvements by identifying stepping stones. Okay, I mean, this is the key word now. This is the key thing. Stepping stones, now capitalized. So identify stepping stones, which are actually empty cells or roots that can potentially uh, reduce costs. So a stepping stone is a path, is a path that moves along field and unfilled cells, field and unfilled cells in a specific sequence, in a specific sequence to adjust the current allocation. Okay. Now we have the third step, which is all about the iterations. So you have iteration. So here, for each stepping stone, for each stepping stone, you need to calculate the cost change, the cost change, and adjust the allocations, and adjust the allocations uh, if it results in a lower total cost. Okay. And then you continue this process until no further improvement can be made. Okay. So that goes. Um, yeah, I mean, as you can see, right? Overall, right? Overall, this method helps find helps to find optimal solution, the optimal solution by systematically improving the allocation of goods, the allocation of goods between sources, or what you can call suppliers, between sources and destinations, which are the consumers, and destinations, minimizing overall transportation costs. Overall transportation costs. Okay. So that's the brief thing about the stepping stone method. Let's take an example now. Let's go for an example. Of course, I make sure I'm using the same problem about three suppliers and three consumers, right? Uh, so in this case, since we have already used the northwest corner rule and the least cost method to get the initial feasible solution, then I'll just import that here. Interestingly, we got the same thing from Northwest Corner Rule and least cost method. But the Vogel's approximation method, its own is a bit better. I mean, it's different, right, from those first two methods. And because we had actually solved using linear programming from the beginning, right? The Vogel's approximation method is exactly the result we got from the linear programming style using Python code. So we can believe that the Vogel's approximation method is optimal already. So that's why it's better to use not the result from Northwest Corner Rule and the least cost method. So I'm just going to do all this now. So S1, S2, S3, these are the three suppliers. And then we have our consumer C1, C2, and C3. Um, so here now we have all this. Okay, well, I guess we can still indicate the supplies and demands. Okay, so let me write the cost in the corners here. 8, 6, and 10. These are the costs. And then we have 9, 7, and 4. And then we have here 3, 4, and 2. Okay. And of course, from the optimal solution, from the initial feasible solution, from uh from the northwest corner rule, we had 80 allocated here, 20 here. Then we had 120 here, we had 30 here, and then we had 120 here. That was our uh, initial feasible solution. Okay, so here we had our supply. As you can see, 80 plus 20 is 100. 120 plus 30 is 150. Then yes is 120. So that the total is 370. And here we have the demand also, right? The demand. That's 80 for this. Then we have 140 here. That's 120 plus 20. And then we have 150 here. So if you add everything together, this is 290 plus 80. So you see that everything here is 370 for demand and supply. So we have a balanced thing. So we don't need to do anything extra, like I keep saying. Okay, so this is the initial feasible solution, right? Initial, so so the table above is the initial initial feasible solution from the northwest corner rule and the least cost method, same table emerged. So what is our goal now? So our goal is to optimize optimize the solution. If it is, if it is, if it is, okay, well, maybe let me state it in in a better way. So let me say now okay, our goal is to check for optimality. I think this is a better way to go. Check for optimality. Okay, that's the first goal. And optimize if necessary. Check for optimality and optimize if necessary. So that's our goal here. So since we are using the stepping stone method, right? Um, so what we now have to do, I'll just go ahead and say and do solution. So again, let me just draw out the table. We have S1, S2, S3. Okay. And we have C1, C2, C1, C2, C3. Okay. And then Okay. Again, we have the costs, right? 8, 8, 6, 10. Then we have 974, 974. And then this is 3, 4, and 2. 3, 4, 2. And we have the allocations. This is 80, 20, 120, 30, and this is 120 here. Okay. What's happening here? Okay. Uh, okay. Okay. This is S3 now. So we have 3, 4, 2, 3, 4, and 2. And then for the allocations, like I said, 80, 20, 120 here, 30 here, and another 120 here. So we have the supply again. Supply 100, 150, 120, and then the demand is 80, 140, 150. Everything ties to 370, given a balance in the demand and the supply. Now, from this stepping stone method, right? This is what is going to happen. So we have to take note of the unassigned cells. So this cell is unassigned. For instance, nothing is assigned here in the initial feasible solution. Nothing is assigned here. Then nothing is assigned here, and nothing is assigned here. So we have 4 cells unassigned. So uh, so let me just say that we have 4, right? We have 4 unassigned cells, 4 unassigned cells, namely uh S1, S3. So we can call that what should I call that now? Okay, that is supplier 1, consumer 3 if you like. Or maybe to make it easier, namely cell 1, 3, cell 2, 1. Okay. This is cell 1, 3. This is cell 2, 1. This is cell 3, 1. And this is cell 3, 2. So these are the 4 cells, 4 unassigned cells we have. So what we are going to do is this. So the whole idea of the stepping stone method is this. Is that if we take 1 unit of product to any of the cell, is it going to affect the overall, is it going to save cost in any way? And the way to do that is we are going to form closed loops. And that way now we can compute for each cell. So we say for cell for supplier 1 going to cell 3, going to consumer 3 now, see what is going to happen. So in this case, imagine if we assign 1 unit here. So of course we have to balance it out. So if you assign 1 unit there, right, we have to subtract the 1 from here so that we can maintain our balance. And then if we subtract, so you have to balance it across the row and down the columns, right? So plus and minus here, we have balance for row, but column, because of minus here now, we have to balance this one with plus and this is with minus. So we have a closed loop in that case. So with that closed loop now, so if you assign 1 here, it means we are incurring a cost of 10, right? So it means you're going to have 10 minus the cost in the other cell, that is 6. That is 10 here, 6 here. Then we have 7 below that. All right. So this is plus 10 minus 6 plus 7 minus 4. Okay. So this is going to give us 10 minus 6. That's 4. 4 plus 7, 11. 11 minus 4, that is 7. So we have 7 there as what that loop is going to give us, which is positive. Okay. So that positive number means that um that may not have any impact if we add an extra um if we have a unit of product there in cell 1 3. Okay. Now we have finished for this one. Okay. So that's done. So the next thing is we now come here. So we come to this place for cell S2 C1. So we say for S2 to C1, what do we do? So this is S2 now. So imagine you add a cell here. Okay, add 1 unit of product here. So if you do that, then you have to subtract 1 from here to balance it. And you have balance for the column. So for row now, since you have subtracted from here, you have to balance it here. And then you have to subtract here to now balance for this other row. So everything is uh, good like that. So in that case, what do we do? So in cell 2 1 where you're starting out from, so you have 9, then at the top you have -8. So just focusing on the cost now, -8. Now you discover that we have one cell unassigned with every other cell is assigned, right? So we have 9 minus 8 plus 6 minus 7. 9 minus 8 plus 6 minus 7. That's 9 minus 8 plus 6 minus 7. Talking about the costs. And this gives us now 9 minus 8 is 1. 1 plus 6 is 7. 7 minus 7, that gives us 0. So the next thing now, we go on to, okay, maybe I should have just maintained that before this is, so here we had plus, okay, plus, minus, plus, minus, okay. So if I use different markers, I can keep up with the flow, okay. Then the next thing is S3 to C1, supplier 3 to consumer 1. So we have for supplier 3 to consumer 1, what does that give us? Now, I guess this is going to be a bit trickier. So let me totally change the marker. Say I go, let me use something totally different. I don't know. So, okay, let me go blue now. All right. So, um, so our focus now is shifting to supplier 3, consumer 1. So if you look at this, I guess I need to erase all this to avoid confusion. So we can see that. So, the focus is on one assigned cell and every other thing has to be one unassigned, every other thing has to be assigned. So this is our cell now, the new cell we're focusing on now. So here, if you add 1 here, then you have to, since 1 was assigned here, you cannot do minus here because there's nothing assigned. There's nothing to subtract. So we can only subtract from where something is assigned. And then you see, because we have jumped that now, we have to balance this up. And if you balance that up, then you have to subtract from here to balance up still. But then you have created another row which needs balancing. So in that case, you have to add here, but then you have created another column that needs balancing. So you now have subtraction here. So everything has, so we have to find our way around like that. So you add 1 unit of product to from supplier 3 to consumer 1. So you have to subtract 1 from the 80 that was there before. Then you have to now add 1 to the 20 that was there to balance up. So you can still, if you subtract 1 here, you have 79. 79 plus 20 is 99. So you need 100. So you have to add the 1 here. So you have 79 plus 21. Then because this one has to be 40, now this is 21. 21 plus 120 is 141. So you have to subtract 1 from here so it can balance up. And now that you have subtracted from here, so it's now 119 plus this. So you have 149, but you have to balance 1 by subtracting. So, just do plus minus around like that to get the kind of value you need to get. So now for S3 to C1, we now have +3 where it started out from, then -8 as the cost for that. Then next we have +6 minus 7. So +6 minus 7. And that's not all. We have, so plus 6 minus 7, we now have plus 4 minus 2. This is 2 now, plus 4 minus 2. We have plus 4 minus 2. So what does that give us? So 3 minus 8 is 5. 5 plus 6 is 11, right? 11 minus 7 is 4. 4 plus 4 is 8. 8 minus 2 is 6. Is that correct? 3 minus 8 is minus 5. Minus 5 plus 6 is 1. Oh, so what did I say? 3 minus 8 is minus 5. Okay. 3 minus 8 is minus 5. Minus 5 plus 6 is 1. 1 minus 7 is minus 6. Minus 6 plus 4 is minus 2. Minus 2 minus 2 is minus 4. Okay. See that. So what did I do previously? So let's add the positive ones. 3 plus 6 is 9. 9 plus 4 is 13. Then the negative ones are 8 plus 8 minus 8 minus 7 minus 15 minus 2, that's minus 17. So 13 minus 17, that's minus 4. Okay, that's fine. So you can see that one had to take we have to balance things out like that. So we have one more cell, which is this one now. Okay, I can leave what I had before. So we have this cell, the last cell now, that's S3 to C2. So we have for S3, supplier 3 to consumer 2 now. So we also have to balance things up. So if we add 1 unit here, so if we add 1 unit here, that's plus here, then we can have minus here to balance things up. We can have plus here to balance things up, and then finally minus here. So we have a closed loop there. So we can just do that, and that will be 4. Okay. This 4 minus 4 minus 7 plus 4 minus 2. 4 minus 7 plus 4 minus 2. Okay. 4 minus 7 plus 4 minus 2. And that will be equal to 4 minus 7 is minus 3. Minus 3 plus 4 is 1. 1 minus 2 is minus 1. So as far as we have, so you can see we have negative values here. So we have this minus 4 and this minus 1. So it means that we can still improve a lot allocations. And the particular one you want to improve is the one that is most negative. So it means that this most negative one will have a better impact. So in that case, now we can go to, so we now look at cell 2. We look at cell 2, supplier 2 to consumer 1, S3. So so now we have, it means that we, we have to focus on this particular cell because it's giving us the most negative, supplier 3 to consumer 1. So in that case, now it means we are going to add, so what can we add, right? You see, supplier 3 is willing to give 120 and consumer 1 is willing to take 80. So we can assign the whole 80. All right. So what you would usually call that is theta, right? So you can say this is plus theta minus theta plus theta. Okay, so since we are going this way now, we have to do it round. So just make it theta all round like that. So, and from what we can see like this, since this is consumer 1 is willing to take 80 and supplier 3 has 120, so we can give the whole 80 there. So as far as we have minus 4 and minus 1, we can still improve the solution. All right, starting from cell C1. I mean cell 3, 1, which gives the most negative value, which gives the most negative value. Okay. And we start we start by assigning 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 theta equals 80, from what we can see, right? So for this cell now, the whole of consumer one is willing to take 80, and supplier 3 is willing to supply 120. So we even have excess. So we start by assigning theta equals 80 and balance balance things out in corresponding cells. Okay. In corresponding cells. So in that case now, I can redraw the table. So now I have, let me redraw the table, and I have supplier 1. I have supplier 1, supplier 2, supplier 3, and then consumer 1, consumer 2, consumer 3. Okay. So we have all this now. So in this table, I'm going to have, of course, the costs remain the same. We have 8, we have 6, and we have 10. And then here we have 974, 974. And then here we have 342, 3, 4, and 2. Okay. All right. So now, so from cell C13, right? We are we are going to have theta. Theta is 80. So in cell 3, 1 rather, we have 80. So the assignment now, we have cell 3, 1 is 80. And since we have 80 there, at the top before there was 80. So that 80 minus 80 now, okay? Since we are subtracting theta from there, which is 80. So 80 minus 80. So this one now has no allocation again. And then we have 20 plus 80 in 1, 2. So that means we have 100 moving there. So all of that is to balance out whatever we need to have there. Then, so now we now go to cell 2, 2. That's 120 minus 80. So here now, cell 2, 2 is 40 now. And then I think we now shift to the right. So where we have 30, it was 30 before, so we have to add 80 to that. It becomes 110 in cell 2, 3. In cell 2, 3, we now have 110. And of course, we shift down now. So when we shift down, we have 120 minus theta, which is 120 minus 80. So that's now 40. Okay, this is now 40. So now, how do you know if you are still in order? You have to check to see if the supply and demand supplies down the columns and demands across the rows are still in order. So this is still 80, this is 140, this is 150, and that was what we started with. Then for the supply, right, this is still 100, all right, this is 150, and this is 120. So we're in good shape. So how do you know if you have actually, if this actually improves your results? So in this case now, of course, we now have new, so new solution. To make things easier, I'll just say we now have as you now have S1 to C2. S1 to C2 is 100, right? S1 to C2 is 100. Then next you have S2 to C2 is 40. S2 to C2, that is 40. Then next you have S2 to C3 is 110. S2 to C3 is 110. Then you have lastly, oh, that's not last, right? You now have S3 to C1 is 80. S3 to C1 is 80. And finally, you have S3 to C3 to be 40. S3 to C3 is now 40. So that's our new solution. right? So 140, 110, 80, 40. 140, 110, 80, 40. And what is now the total cost in this case? Total cost now, of course, as you know it, that will be 100 times 6, or say 6 times 100. That's the cost in that cell times 100. Then the next one will be 40 times 7, 40 times 7, plus the next one is 110 times 4, 110 times 4, then plus the next one, um, 80 times 3, then 40 times 2. 80 times 3 plus 40 plus, okay, I mean, I've mixed it up now. 40 times 2. I wanted the cost to come first before, but that's okay. So let's check again. That's 100 times 6, 40 times 7, 110 times 4, 80 times 3, 40 times 2. So let's see what that gives us. That is 600 plus 280 plus 440 plus 240 plus 80. And what does that give? 600, 280, 440, 240, and 80. So let's see what that gives us. So we have 600, 600 plus 280 plus 440 plus 240 plus 80. And that is 1,640. Interesting. So now this gives us a better result. You know, the from the initial tableau, right? If you remember, from here now, we had our total cost here was actually $1,960. Okay. So that was the total cost. If you check again, you get $1,960. So this is definitely an improvement on what we have before. But you see, but the question is this an optimal solution? So we have to check if the solution is optimal again. So, and how do we go? We have to check for the empty cells again. Okay. Um, so the the therefore the new cost is $1,640, which which is an improvement, on the $1,960 obtained from the initial feasible solution. Okay. So again, we can still check for optimality. So check for optimality of the current solution. We can check of the current solution. So again, we use the stepping stone method. So now we look, what are the unassigned cells? Well, I guess can I withdraw that? That won't be too much of stress. Um, okay, I guess I have to withdraw the table. I think it's worth it. What do I do now? Okay, let me just go. Um, so I have S1, S2, S3 again. Then I have C1, C2, C3. Okay, then all this, right? Then I have all this, right? Now, let's go again. The cost don't change, the cost remain the same. So we have 8, 6, and 10. Then we have 9, 7, and 4. Then this is 3, 4, and 2, right? But now we have new assignments. This 100, okay, that's 140, 110. 140, 110. Okay, S1 to C2, 100, right? S1 to C2, 100. Then S2, S2 to C2 is 40. S2 to C2 is 40. Then S2 to C3, S2 to C3 is 110. S2 to C3, 110. Then what else? Um, S3 to C1 is 80. S3 to C1 is 80. Okay. Then S3 to C3 is 40. S3 to C3 is S3 to C3 is 40, right? That's the last one. Okay, yeah. 10, 100, 40, 110, 40, 80. Okay, so again, the supply is still intact. The supply is still intact. We have 100, we have 150, we have 120, and then the demand is still intact also. We have 80, we have 140, and we have 150, and everything adds up to 370, both demand and supply. So now we want to check again if we have optimality in place. So we have to check for optimality, right? So we say so now we have new cells. So we have the new cells that are empty are this, this, and this now. So let's see how we can work around this. So the first one is for S1 to C1, S1 to C1. So let's look at how the signs go. Let's do this. This is if we add one here, okay. If we add one here, um, okay, this is really tricky now. If we add one here, we can subtract one here to balance up, but then we have to add one here to balance that column. But that's not all. Then we have to now balance this row. Okay, we have to balance this row by subtracting, and then we have to balance the column by adding. So we have it going all that way. Right. I mean, if we come down, it won't be that easy. But we could do that. We could come down too, right? We could actually come down. Yeah, we could do that actually. Mm, yeah, but this is fine too. So make sure every row and column is balanced. So that's 8 minus 6 plus 7, just the cost. 8 plus 6 minus 8 minus 6 plus 7 minus 4 plus 2, right? 8 minus 6 plus 7 minus 4 plus 2. So that's 8 minus 6 is 2. 2 plus 7 is 9. 9 minus 4 is 5. 5 plus 2 is 7. Okay, that's for S1 to C2. Okay, then the next one is for S1 to C3. So for S1 to C3, S1 to C3. So this is now so if we add 1 unit here, okay, we can subtract from here, add here, and subtract from here. So we have something close that we can balance up. So we have, that'll be 10, okay, that's 10 here plus 10 here, minus 6 plus 7 minus 4. 10 minus 6 plus 7 minus 4. 10 minus 6 plus 7 minus 4. Okay, 10 minus 6 plus 7 minus 4. So 10 minus 6 is 4. 4 cancels 4, so this also gives us 7. So 10 minus 6, 4 plus 7, 11 minus 4, 7. So we go for the next empty cell, which is S2C1. For S2 to C1, for S2 to C1, okay, for S2 to C1, now, okay, let me use a green marker. For S2 to C1, we can add 1 here. So if you add 1 there, okay, we can of course, we can subtract here to balance things up. And if we subtract there, we can add here again to balance things up. And uh, to balance the column, we can now subtract here again. It looks like the green is, the green is disappearing into it. So I guess, okay, well, that's fine. So we can balance this by subtracting that, right? You can subtract from here. So plus, minus, plus, minus. So we have the loop closed like that. Yeah, I think that works. Yeah, that works. So we can have plus 3. That's 3 here, plus 3. Oh, sorry. That should be minus actually. So it should be 9 minus 3. So 9 minus 3 plus 2 minus 4. Okay. 9 minus 3 plus 2 minus 4. 9 minus 3 plus 2 minus 4. 9 minus 3 is 6. 6 plus 2 is 8. 8 minus 4 is 4. Okay. Then we now have for the last one, this is S from for S3 to C2. S3 to C2. For S3 to C2. Okay. Uh, I'll have to change the marker completely so I can monitor that. So for S3 to C2, so if we add 1 here, we can subtract from here to balance things up. And then we add here, and then we subtract here. So we have the closed loop for that. So that'll be 4 minus 2 plus 4 minus 7. 4 minus 2 plus 4 minus 7. 4 minus 2 plus 4 minus 7, right? Let's check that to be sure. 4 plus 2, right? 4 plus 2, just follow the black. 4 plus 2, no, 4 minus 2 plus 4 minus 7, okay? 4 plus 2, 4 minus 2 rather, plus 4 minus 7. So this is 4 plus 4 is 4 minus 2 is 2. 2 plus 4 is 6. So we have minus 1 here. So again, we have something to improve on. So it means we have not, so we still have something to improve on. And that improvement has to happen in cell 3, 2. Cell 3, 2. So you see cell 3, 2 is here. So this is where our improvement has to happen, cell 3, 2. So again, you can add theta. Okay, so we're adding theta here. So if you add theta there, you have to subtract the theta here. So follow the black. Follow the black. Black is what is giving us this. So now, how do we know what to do with that cell? So this cell now, whatever the theta is, maybe you can, okay, so that place is willing to supply 120, but the whole column requires 140. So I guess we can assign the whole 120 to that, and our theta will be one. But if we take theta to be 120, if we subtract theta from if we subtract theta from 40 to give us negative, so that won't work. So we can say, okay, we can just look at the smallest number, that will make sure we don't get any negative. So, and that will be 40. So we can take theta to be 40 now, okay? Theta is 40, because you can say 40 minus 40 is 0. 110 plus 40, you can get something. 40 minus 40 will still be 0. But if you take 120, 40 minus 120 will be negative, and we don't want to have that kind of situation, okay? So we need to have a new table then. So we have S1, S2, S3. Now this is really a long one. Then we have C1, C2, and C3. Okay. Um, and then we have all this. We have all this. So again, the first thing is put the cost because those do not change. So you have 8, 6, 10. Then we have 9, 7, 4. And then this is 3, 4, and 2. So now what are the new allocations like? S1, C2 doesn't change. So we have 100. Okay. So we have 100 allocations remain here. Then S2C2 is 0 now. S2C2 is 0 because 40 minus theta, the theta is 40. So 40 minus 0, 40 is 0. Then, of course, down here, we now have the 40 is shifting down here now. Then, so here, so it has to be 110 plus 40. So beside that 0, right, we have 150. So beside 0, we have 150. And then, but 40 minus, so here 40 minus theta is 0. Okay. 40 minus theta is 0. So we have that shift taking place. Okay, I think to the right, nothing has changed. This 80 remains. So 80 remains here. So you want to check to be sure everything is still in order. So look at the demand side. You have 80, you have 140, you have 150. So that's like what it started out with. Then look at the supply side. You have 100, you have 150, and you have 120. That is still like what we started with, right? So everything still adds up to 370 before. So we are good. So the next thing is you want to calculate the cost. So I won't bother writing out anything here now because this is taking more time than I can imagine. So just multiply out. So we have total cost now is 100 times 6. That's here. Then next we have 150 times 4. That's here. Then next, we have 80 times 3 plus 40 times 4, right? Right, that's 100 times 6 there, 150 times 4 here, 80 times 3 here, then 40 times 4 here. Okay, so we now have this to be 600 plus 600 plus 240 plus 160. Now, does this look familiar? 600 plus 600 is 1,200. 240 plus 160 is 400. 1,200 plus 400 is 1,600. Yay. This is exactly what we got when we used Python initially. So I I am sure most likely that we have reached an optimal solution. But I mean, we cannot just assume we have reached. We have to do the normal test, right? So the question now again is, so we now need to check for optimality. Of course, it goes without saying that 100 will be assigned to from S1 to C2, 150 will be assigned from S2 to C3, 80 will be assigned from S3 to C1, and 40 will be assigned from S3 to C2. So I'm just not writing all of that out because of so much time we've spent. So we may want to just try to check for optimality this one time. In fact, even if it doesn't reach optimality, I'll just terminate there because you already know the process. But of course, I believe it has reached optimality because this is familiar. Check for optimality now. So to check for optimality, we do the usual thing we do. All the empty cells, we check them out to see if we still have any negative values. So if there's no negative values, then we have reached optimal solution. So we want to check for all this now. Okay, all these zeros too can go, right? Anything zero, normally it means there's no assignment. So, okay, all the zeros. Mm. No, how do we check for optimality again? Yeah, is it by assigning? Okay, yes, yes, yes. We have to. Ah, this is serious. Okay, let's do it. But I believe we have reached optimality actually. So let's just do. Okay, shifted something there. Okay, so let's say to check for optimality, right? We start with S1, C1. So okay, for S1 to C1, right? What do we have? So S1 to C1, imagine if you assign a unit here, okay, or let me use a totally different color. Say let's go green now. So if you assign one here, you subtract one here to balance things up. Then you can assign one here and subtract here. So that way we can have things balanced up. So so we have, that'll be 8. Okay. That'll be 8 minus 6, 8 minus 6 plus 4 minus 3. 8 minus 6 plus 4 minus 3. 8 minus 6 plus 4 minus 3. 8 minus 6 is 2. 2 plus 4 is 6. 6 minus 3 is 3. That settles that. So we can have for, okay, this is still green color. Okay, we already had green, right? Let me go this. Okay, maybe it doesn't add much difference. Okay, so that's S1, C1. Then we go for the next one, say S1, C3. Okay, so for S1 to C3, for S1 to C3, what do we have? S1 to C3. Imagine that we add S1 to C3, right? If we add 1 unit here, then if we add 1 unit there, right, we can if we add 1 unit there, how do we balance this up now? Okay, if we add 1 unit here, it's becoming, if we add 1 unit in that place, how do we balance in that column? So this is plus, we add 1 unit here, because we can subtract 1 here. And if we subtract 1 there, then we can, is there an assignment I did not do here? Okay, that's already gone to 0. Okay. Okay. Should I take the fact that it is impossible to even balance anything there to say that there's no improvement we can make, right? Okay. Um, so plus minus, add here, subtract here, add here, add here, add, subtract, add. Okay. Um, subtract. Yeah, I mean, so from the look of things, right, it's looking like we can't even find a way to balance things out. So, and this is undefined, right? So, I guess I just want to stop here. So, and of course, this solution already aligns with what we got from from, you know, using Python. So, it's, um, it's, looks like we have reached an optimal solution, solution, you know. And what is the optimal solution now? Um, you assign from S1 to C2, S1 to C2 will take 100 products. Then what else do we have? We have S2 to C3 will take 150. S2 to C3 will take 150 products. Okay. S2 to C3 takes 150 products. Then S3 to C1 80. S3 to C1 takes 80 products. Then S3 to C2 will take, I think, 40, right? Will take 40 products. Okay. All at a total cost, of $1,600. So this aligns with what we got from linear programming. It aligns with what we got from Vogel's approximation method. So this is how you use stepping stone method to optimize your initial feasible solution. So I still have one more video to go on this kind of thing. That's talking about the modified distribution method. So you want to watch out for that. So if you have not subscribed to this channel, be sure to do that right away. Hit the notification bell so you can always get notified each time a new video is released. Comment to let me know if you want me to teach a topic or solve a problem, and then like and share so that more people can have access to this. Till I come your way again, keep optimizing. Bye.